So applications, right? Euphemism for story problems. So we're going to do story problems with rational equations, fractions. And the first one that we're going to look at is work rate problems. So work rate is when you're sharing a job. So here is a formula, which, oh my gosh, I was teaching before I learned this formula. It is so helpful. So this is, it's kind of like distance equals rate times time. It is just a formula and we get to use it. I'll explain what everybody is. So t over a plus t over b equals 1. So a, that first denominator, is the time for one person or one pump or whatever it is that's working. Time for one thing to do the job alone. B, the other denominator, is the time for the other person to do it alone. I was thinking ahead, alone. T is the time together. And so we talk about work rate. That's because the first person's rate, right, is 1 over A. So 1 over A is, right, the first person's work rate. All right, so with that formula, now we're going to go ahead and take a look at our first example and figure out who everybody is and what it is we need to find. So it takes Tom 4 hours to paint a room. It takes Angie 6 hours to paint the room. How long if they paint together? Okay. So what I usually do with word problems, if I recognize what formula it is I'm supposed to use, I write it down, because then I know what letters I need to find, or what numbers I need to find for the letters. So my formula has 3 different variables in it, T, A, and B. So T is the time together. Okay, and so that's what I want to find, so I don't know that. A is the time for one person, so A can be Tom's time, so he's 4 hours. B is the other person's time, so that would be 6 for Angie. And then we're going to plug everybody in. So T over 4 plus T over 6 equals 1. Okay? So how do I solve an equation like that? Well, you have some options. You could just get a common denominator and add these 2 fractions on the left. Should we do that? Okay, so what's the common denominator between 4 and 6? Shucks, oh my gosh, that kind of day, I guess. So yes, 12, so my lowest common denominator is 12. So I'm going to build everybody up to have that. Second fraction, top and bottom by 2. I'm not going to do anything to the right side because I'm just working on the left. So now my left side is plus 2 times t over 12 equals 1. So now I can add those 2 together. So same denominator, so that'll be my denominator, and then it's 3t plus 2t. So that's 5t. Okay, so 5t over 12 equals 1. So now how do I figure out what t is? So you can do this in 1 step or 2, or right, however you're going to come about it. So one of the ways you can see it is, okay, I need the 12 gone, so I can multiply both sides by 12. Right, what happens over here on the left is this 12 cancels that 12 that was in the bottom. So I just get a 5t, and then 1 times 12 is 12. Okay. And now 5 times t is 12, so to get the t by itself, you have to divide the coefficient. So t is 12 fifths. Oh, off screen, there we go. 12 fifths, and it looks like we are in hours. So it is that 2 hours and 2/5 of an hour. Okay. So 2 hours, 24 minutes if you want to be more human-like and less math-like. All right, so here's your second example for a work rate. So if you want to pause and see if you can do it by yourself first, I would encourage that. Okay, so here we go. Work rate, it says, 1 hour longer, da 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 da. Okay, so T over A plus T over B equals 1. Okay. It takes Anna 1 hour longer than Taylor to mow the lawn, and it takes them 6 hours if they work together. How long for each person alone? Oh, well, this is tricky. Okay, so let's see. Here's my formula. So the letters I need to find, A, B, and T. So this time, I know it takes them 6 hours together. Remember which letter that one is? Right, that's my T, so T equals 6. So what am I going to plug in for A and B? Right, so Anna is 1 hour longer than Taylor. So if A is just A for, right, the amount of time for one person, and the other person takes 1 hour longer. So the same amount of, right, same, plus an additional hour. All right, so what is that going to do when we plug those into our formula? So it looks like this is Taylor and Anna. Okay, so here we go. So T, now being played by 6, over A is just A, plus T, still a 6, over B, I'm going to put in the A plus 1, right, so that I have just my one variable there. And now we need to solve that. Oh, so should we use the same strategy we used before? So we'll go ahead and build up both of these fractions to have a common denominator on the left. So the first fraction, no, I can't just add one, remember? It has to be a factor. So this is A. It needs to also have a whole factor of A plus 1. So we'll have an A plus 1 for the bottom and an A plus 1 for the top. Second fraction, right, it needs an A and an A plus 1. It has the A plus 1 factor. This A here is not the same as that A, because this A in the right fraction is attached with a 1. So I can't, right, it's not a factor in my second fraction. So I need an extra factor of times A. Right? You know it's a factor if you can say A times. Let's see, notice I put my parentheses also around the A plus 1 in that second fraction, because that's the binomial, so that A would actually multiply in. All right, so let's go ahead and see where we are. Oh my gosh, we've got 6 parentheses, A plus 1 over that LCD, A times A plus 1, plus 6A over, again, A times A plus 1, and that equals 1. So now they have the same denominator, so we can go ahead and add those together. I might distribute my 6 on the left side fraction as well. So I have A times A plus 1 is my denominator, and I'm going to get 6A plus 6 plus 6A. What do I have? I hope I don't run out of room here. I should have started going sideways. So I have 12A plus 6 over A times A plus 1 equals 1. Oh my gosh, that's a lot of work, and we haven't even solved the equation yet. So I need to, right, clear my denominator. So I'm going to multiply both sides like before. When I multiplied both sides by 12, I'm going to multiply both sides by A times A plus 1. All right, some students are going to stick a 1 under it so it feels better. So over here, my left fraction, I have the exact same, right, set of factors, top and bottom, so I get to cancel those. That was the goal. I'm just left with 12A plus 6. And then over on the right side, I have 1 times A plus 1, so I'll distribute this A as well. So I'll have A squared plus A. I'm not sure this is going to be nice enough for us to solve. And then I'll subtract 12A from both sides. and I'll subtract 6 from both sides. I'm doing this because I have a quadratic equation, so I need to have a side equal to 0. I'm choosing my left side to be 0, so I have 0 equals a squared minus 11a minus 6. Well, that's just not feeling good to me. Let me take a quick little look over here because we do not have a strategy to solve this until we get to Math 99. 6 hours. How long for each person alone? Okay, I think I've got it set up okay until then. I'm so sorry, but we can't solve this because it doesn't factor, so we can't solve it until we learn chapter 11, unfortunately. Okay, so we'll meet back up here in chapter 11. Fingers crossed, none of the questions in your homework turn out like that. Hopefully they all factor once you get there. Okay, so let's see. Hopefully my next one's going to be better. Distance equals rate times time. So distance equals rate times time. So D stands for distance traveled usually. R is the rate, speed, something like that. And T is the time. Okay. And as I have written there, I almost always use a table for these. So here we go. Current in the river is 4 miles per hour. If I can paddle 6 miles upstream in the same time it takes to go 12 miles downstream, how fast can I paddle in still water? Okay. So, once you get used to these, they just kind of follow a pattern. And try not to get too freaked out about them because they'll all be fairly similar. So here's my table. I have a distance, I have a rate column, and I have a time column. Okay. And then I have two things going on, right? I'm paddling upstream, so I'm going to say up. And then I'm going to go back downstream. Okay? Now sometimes it'll be a boat travels and a plane travels, or somebody's driving east and somebody's driving west. Something like that. So this is up and down. So it says the current in the river is 4 miles per hour. So current, well, first off, miles per hour, that's a clue that that's a rate. Okay? So I don't know what I'm going to do with a 4 yet, but I'll hold on to that information. I can paddle 6 miles upstream, so that's a distance, and it's up, so I'm going to put a 6 in the up distance cell. In the same time, same time, that's a clue. Okay, so I'll underline that. It takes to go 12 miles downstream. Okay. How fast can I paddle in still water? So the thing I don't know, so here's my question, right? How fast can I paddle in still water? How fast? That's my rate. So I'm going to let R equal my rate in still water. No current. That's what still water means. Okay, so upstream, that means I'm paddling against the current. So my net speed is my paddling speed minus the current. So the current's right working against me. So rate minus 4, right, speed of the current. I'm bringing that in. Whereas if I'm going downstream, right, I have my own speed, right, that I can paddle in, but the current is helping me out, so R plus 4. Now there's something sneaky in here. In the same time, so the time in this cell has to equal the time in this cell. So my time upstream is the same as my time downstream. Okay, so here's what we're going to do. You see our formula up here? Distance equals rate times time. Let's solve that for time. So distance equals rate times time. So if I solve that for time, I would divide both sides by R. So time equals distance over rate. Is that okay? So what I want to do then is in each row, we're going to write an expression for the time by using the distance and the rate. So I'll have in my top one for upstream, it'll be the distance of 6 over a rate of r minus 4. And for downstream, I have a distance of 12 over a rate of r plus 4. With me so far? I know. One more thing, and then we can start the algebra part. In the same time, these two are equal, so what I'm going to do is I'm going to grab those two expressions, the 6 over r minus 4 and the 12 over r plus 4, and set them equal. Okay, there's the same time. So now for this equation, 1 fraction equals 1 fraction. Oh, that's the glory days, right? Now we get to cross multiply. So multiply 12 times r minus 4 and 6 times r plus 4, and distribute 12r minus 48 equals 6r plus 24. This is a linear equation because my r's are to the first power. I don't have any r squares, so I don't have to worry about factoring. That's good. So when it's linear, you grab all your r's on one side, all your constants on the other side. So I'm going to subtract 6r so that my r's stay positive. So minus 6r from both sides. They cancel on the right. 12r minus 6r is a positive 6r. That's cool. And then the 48, the minus 48 is going to go over to the other side. And I do that, remember, by adding 48. So just a quick reminder, I add 48 because negative 48 plus 48 is 0. So that gets rid of the 48 here on the left. And then I add the 48 here on the right side of the equal sign because I want to keep it balanced. Same thing to both sides of the equation. Okay, so 6r that we started with equals, stays there, and then I have 24 plus 48, what is that, 72. And then to get r by itself, so it's 6 times r, to get rid of the 6, to undo times, we divide. So divide both sides by 6. Cancels on the left as I wanted, and I get r equals, and then 72 divided by 6 is 12, and this is in miles per hour. Okay, and that is exactly what I wanted, my rate in still water. Perfect. Okay, last one, proportions. Okay, so similar triangles. Well, first off, proportions. So this is something that you use in cooking if you ever have to scale a recipe. Similar triangles, catch and release data. Trying to think of other examples that come up in your book. Well, I guess you guys will tell me. So here we go. So first off, what are similar triangles? Well, they're triangles that have the same angle measurement. So I've drawn two right triangles, so this little square means that that's a 90-degree angle. So any triangle with a 90-degree angle in it is a right triangle. Non-right triangles can be similar as well, but I'm just showing you with a right one. So the similar triangle, all three angles are the same. So if the three angles are the same, right, so this angle and that angle are the same, this top angle and the other top angle are the same, then the ratio of the corresponding sides is also the same. So we'd say A is to X, right, because they're between the right angle and the one with the one slash on it, as B is to Y. So the ratio of corresponding sides is the same. Now you could also, right, we could have done that with the C and the Z, and right, it goes up here too. So then let's see, C is to Z. You could do a ratio the other way as well. You could say B is to A as Y is to X. That would work as well. You see what I did? So I could go within the same triangle, right, B to A, as long as I go in the same order on the other triangle. So, right, the B and the Y are on the same side, and the A and the X are on the same side. Okay, so here we go. The shadow cast by a 9-foot tall tree is 15 feet. How tall is a tree that casts a 25-foot shadow? So this is a common similar triangle problem. So I'm going to draw a quick little picture. So I have a 9-foot tall tree. And it's casting a shadow that is 15 feet. Okay. Here is that right angle. Okay. So now I'm saying, how tall is a tree? So now I've got a different triangle, or sorry, different tree. And its shadow is 25 feet, but I want to know, how high is it? So as long as you're grabbing your shadows, your shadow lengths at the same time of day, right, the angle of elevation, and on the same day, right, the angle of the sun is going to be the same for both. So if they're both right angles, and the angle that the sun makes is the same, then this angle down at the bottom also has to be the same. So I have two similar triangles. Okay. So I'm just going to do the corresponding sides. And I see it here. I'm going to go 9 to 15 equals h to 25. If you set yours up differently, don't worry, we're going to get the same. In fact, I'll leave myself some space and I'll show you a different way we could have done it. But if you got here, I'm trying to get h by itself. If you see it right away, go ahead and do it. If you don't, go ahead and cross multiply. We'll meet at the bottom. But as long as I just multiply both sides by 25, I should get the h by itself. 25s will cancel on the right, so h equals, oh my gosh, I didn't bring a calculator. Let's see, I'll get rid of the 3 first, leave behind a 3 and the 9. I'll get rid of the 5 now, leave behind a 5 up there. 5 times 3 is 15 feet, it looks like. Okay, so real quick, in case you didn't, oh no, the other way. So if you set up your proportion 9 is to h, kind of like I wrote out big up top here. Right, so if you were sort of following this first pattern up at the top, so you'd have gone 9 is to h as 15 is to 25. That's totally fine. Same idea. Now we would cross multiply, so I'd get 15h equals 9 times 25. Let's see. Okay, I really do have, here's a calculator. So 9 times 25 is 9 times 25. 225. So 15h equals 225. So to get to h, I divide by 15. So divided by 15 is also 15. Okay, so you could have gotten there either way. Same answer. All right, so good luck on the story problems.